last matrices note. All right, so this is not points of intersection, because I just covered points of intersection with the matrices 1 note. I am doing the other possibilities now, meaning there's another 8 possibilities. So what we want to do, first of all, and I said this but didn't write it down in the last part, is the first thing you want to do is you want to check to see if your n's have any patterns. So if your normals have any patterns, scalar multiple patterns, and they don't, your d's, you should check those if there's a pattern over here to say that you've got parallel and coincident or parallel and distinct planes. So the first thing you want to do is you want to check for patterns, and in this particular question there are no patterns for your n and your d. N is a vector, d is just a number, a constant. The second thing you want to do with every single question, whether it's this way or whether it's the elimination and substitution, so these steps hold for every method, is you want to check the triple scalar product. So I'm going to do that right here. So 3, -1, 4, 3, -1, 4, 1, -2, 3, 1, -2, 3, -3, subtract -8, 4, subtract 9, -6, subtract -1, so that's 5, comma, -5, comma, -5, dotted with 1, 3, -2, so that's 5 plus -15 plus +10, and that ends up being exactly 0. Now, what that means as in what the 0 means, is that you either have no intersection or you have a line of intersection. So you have to go through a whole bunch of work to figure it out. Now, in my opinion, it's nicer to have no intersection because then you have no extra math. However, if it's line of intersection, we're going to have to introduce t's. So how do you tell between these two? I'm going to go through 3 examples. We're going to have to start this way for every example. But no intersection, you will end up with 0 times t, or I guess 0 times z, if we do it the way we're doing it before. 0 times z, or 0 times t, is equal to some number, which is impossible, because 0 times anything is 0. If you have a line of intersection, it will be all things possible. So that's what we're going to be looking for when we start our matrices. So I'm going to make my matrix. The D is on the right-hand side consistently, so that makes me happy. I'm going to do it here and then pull it down just so I can see stuff. So 3, -1, 4, 8, 1, -2, 3, 2, 1, 3, -2, and 4. And you'll notice what I didn't do is I didn't do any interchanging, and that was dumb of me, but I'm just going to keep going because it really doesn't matter. All right, so I usually lightly circle what I'm aiming to pull off. So I'm aiming to pull off this being a 0. So I have to work with row 2, and according to our list from before, row 1. So they aren't the same number. I'm going to have to take row 2 and times it by 3. Then they'll be the same number, same sign, so subtract. So row 2 times 3 times 3 times 3 times 3. Row 1 as it is. Subtract. 0, -5, 5, -2. Whoa, I'm getting messy. So now I need to deal with row 3 and row 1. And I'm focusing on this. I'll have to times it by 3 and again subtract row 1. So times 3 times 3 times 3 times 3. No change. Subtract. 0, 10, negative 10, 2. All right. So, next step. At any point, you can look at this and say, okay, I can reduce this entire line, or I can reduce this entire line. Like if this was a 20, I would 1/10 this whole line and make it smaller. But I can divide them all by 2, but that really doesn't serve much of a purpose. So you can save yourself a line, which is actually 3 lines of work. All right, so the next thing I want to focus on is getting this to be a 0. So under my diagonal triangle needs to be zeros, is what I'm aiming for. So I'm going to take row 3, but I'm going to work with row 2 because this is my second major step. They aren't the same number, so I'm going to double this one to make it a 10. Then they'll be opposite signs so I can add. So row 3, fortunately, is sitting right here, so I can save myself a little bit of writing. And row 2, double it, double it, double it, double it. And I want to add. So 0, 0, yay. Oh crap, 0, not what I was intending. Negative 2. So that is the replacement. I'm not thinking too hard about this. I'm just tossing numbers in. I'm a bit of a robot right now. Zero, 0, 0, negative 2. Okay, this is a very good thing. This line right here says 0 x's and 0 y's, and this is technically my third row, so I call it my z row. That says 0z is equal to negative 2. Oh my goodness. That's this situation. That means there's no intersection and I get to stop. Yay! And I go on to the next question. All right, here's another one. This is special. Don't worry about it yet. If you go on and take matrices in the future, there are some details that are escaping me right now, but this is a big topic, very much outside of high school. All right, so the first thing I want to do is I want to check for patterns. None between 2 and 3. None between 1 and 2. None between 1 and 3. So no N, D patterns. That does not mean that we get to skip onto matrices. We have to do our triple scalar product test. So 2, negative 3, 4, 2, negative 3, 4, 1, negative 5, 3, 1, negative 5, 3, gone, gone. Negative 9, subtract negative 20. 4, subtract 6. Negative 10, subtract negative 3. So 11, negative 2, negative 7, dotted with 1, 2, 1. 11 plus negative 4 plus negative 7 is equal to 0. So therefore, we are either looking for no intersection. I botched that enough that I can erase it completely. No intersection. or a line of intersection. Again, we are either going to run into the situation of 0z is equal to a number, which for me is preferable because it's less work. You just stop, make your therefore statement, or 0z is equal to 0, in which case you have a line of intersection. All right, so we have determined there is no one point of intersection. That's what we've done so far. So I am going to group this up and make this a little bit smaller. And then I'm going to start the question. So, make your matrix. This time I'm going to be a little bit smarter. 1, 2, 1, 0. There's the third one. 1, negative 5, 3, 0. There's the second one. 2, negative 3, 4, 0. There's the first one. In whatever order I feel like it, as long as I don't make a typo. So, first step is getting this to be a 0. And that will be row 2 replaced. I'll have to work with row 1 and I'll have to subtract. So nothing super fancy. Because my subtraction is happening upside down, I personally am more safe writing it off to the side. Don't say I didn't warn you. This is where the dumb mistakes happen. You aren't dumb. Your mistakes are not the most intelligent mistakes. They're typos. So 0, negative 7, 2, 0. So leave row 1 alone. Replace row 2. And now work on row 3 so you get a 2 for 1 deal. So row 3 with row 1, they're not set up perfectly, so I'm going to times row 1 by 2, and then they're going to have the same digit, same sign, so I'm going to subtract. So I will do that here. So row 3, 0, and row 1, doubled, 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 and subtract. 0, negative 7, 2, 0. Do you see what's happening? Oh my gosh. Unfortunately, even if you have some amazing ability to predict the future of matrices, or your matrix, keep going. Keep going with the system. So row 3, I'm working with row 2 because it's my second major step. Same sign, same number, subtract. And I'm going to get a little bit cocky here. I think I can subtract right in here. 0 minus 0. This negative 7, subtract this negative 7. This 2, subtract this 2. This 0, subtract this 0. And do you see what happened? My Z row tells me 0Z is equal to 0. This is a bit of a disappointment. It means a lot of work ahead of us. So the line of intersection. So, because you've got 0Z is equal to 0, that means you get to let Z equal T. So that is the first parametric equation for the line of intersection. You can then go back and reach into row 2, so go backwards through your matrix, and write down negative 7y plus 2z is equal to 0. So that's this line translated. I'm going to take my z and turn it into a t because of the line up above it. And I'm going to try to solve for y. So that means for me, I'm going to take the zy across the equal sign and change its operation. Divide by 7, divide by 7. So I end up with y is equal to 2/7 that's reduced t. So I've got 2 of 3 parametric equations for the line of intersection. So the last thing I want to do is I want to reach back 1x plus 2y plus 1z is equal to 0. That is row 1 translated back into letters. X plus 2, y is 2/7 t, z is t, equals 0. So that's y plus 4/7 t plus 1t, so 7/7 t is equal to 0. X plus 11/7 t is equal to 0. So x is equal to negative 11/7 t. So therefore, the planes meet in the line x is equal to negative 11/7 t, y is equal to 2/7 t, and z is equal to t, and because I probably haven't impressed you in a while, there's that. Okay, so I am massively hand cramping, so I will be back with this in a few minutes. Okay, a little embarrassing here. Caught my mistake. I don't know if you noticed it. You should have yelled at me. You should not have let me get 16 minutes into this and not told me about this. I know, it's all my fault. It's this question. Like I said, your mistakes do not come from matrices. Your mistakes do not come from calculus. Your mistakes do not come from vectors. They come from really, really basic math. And I made a huge mistake here, and I totally advise you not to fix it the way that I'm about to fix it. So what happened? Well, right here, I did my row 3. Where is my row 3? My row 3 times 3 right here, and I minused my row 1 right here, and I did 12 minus 8 is equal to 2. And last time I checked, 12 minus 8 is equal to 4. And this is what I advise you not to do. It is well worth you restarting a question, but this will now be a 4. It means that I can still pull off this step. I can still write down row 1, I can still write down row 2, I can still take row 2 and times it by 2 and add them together, but it means 0 plus 0 is 0, 10 plus negative 10 is 0, negative 10 plus 10 is 0, 4 plus negative 4 is 0. And do you see why that's a bad thing? Not bad as in evil, not bad as in you're going to have to start the question over. Bad as in that line is no longer 0z is equal to a number. That line is now 0z is equal to 0, and we have a line of intersection. So I get to do what I just finished in the last question, only more of it, and then go on to the third question. Oops for me. So row 2, negative 5y plus 5z is equal to negative 2. Negative 5y plus 5t is equal to negative 2. negative 5y is equal to negative 5t minus 2, or the other way around. Divide by negative 5, divide by negative 5, divide by negative 5. Y is equal to negative 5 divided by negative 5 is 1. Negative 2 divided by negative 5 is a positive 2 over 5. All right, so now back to my line number 1. 3x minus y plus 4z is equal to 8. 3x minus bracket of t plus 2/5 plus 4t instead of z equals 8. 3x minus t minus 2/5 plus 4t is equal to 8. 3x is equal to 8 plus 2/5 on the other side, minus 4t plus t. So 3x is equal to 8 is 40 divided by 5, so 42 over 5, minus 3t, divide by 3, divide by 3, divide by 3. X is equal to something over 5. Use your ABC button if you don't know what I'm doing. 14 over 5 minus 1t. All right, so I can say, now that I've finished the question properly, therefore, the line of intersection is x is equal to 14 over 5 minus t. Y is equal to 2 over 5 plus t. Ooh, I moved that around. And z is equal to t. And because I totally botched this question the first time, I should probably impress you with that. Okay, so now I'm going to take a little break because my hand cramped up again in embarrassment, and I'll be back to finish the last question. Okay, sometimes I just need to flick my hand around to make the pain go away. Cramp. All right, so step 1. No pattern, no pattern, no pattern. That means I can continue for good or bad. Part 2. We're in sync. Okay. So 3, negative 2, 4, 3, negative 2, 4, 1, negative 5, 1, 1, negative 5, 1. So negative 2, subtract negative 20. 4, subtract 3. Negative 15, subtract negative 2. 18, negative 1, negative 13, dotted with 2, 3, 3, my remaining normal. So 36 plus negative 3 plus negative 39. Did I screw up again? That does not equal 0. That means I should have a point of intersection. I don't believe I should. What did I screw up? 3, negative 2, 4, 3, negative 2, 4, 1, negative 5, 1, 1, negative 5, 1, negative 2, subtract negative 20, 18. 4, subtract 3, 1. Shoot! See, I was not expecting a point of intersection, and this should go to show you that do not go about expecting things. Line of intersection or no intersection. Okay. See? It's the easy math that messes you up. All right. Matrices time. Whew. Let's see which situation we have. And as you can see, my hand cramp could not have gone away, otherwise my handwriting would not be this messy. And my D's are all on one side. Remember, if they are not consistently on one side, you have to pull them all over to the right. All right, so again, I failed miserably with putting the 1 in the right position. I'm going to try to get that to be a 0 as my first step. So that's row 2 working with row 1 because it's our first step. They're the same sign, so it's subtract, but I need to triple this line, so I need to triple R2. So times by 3, times by 3, times by 3, times by 3. Leave it, leave it, leave it, leave it. Subtract. 0, negative 13, negative 1, negative 2. Yellow, focus on this guy. So I'm working with row 3 and row 1. They aren't the same number. I'll have to take row 3 and times it by 3 to make a 6, and row 1 and times it by 2 to make a 6, and they're both going to be positive 6s, so I'll subtract. So triple, 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 double, 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 0, 13, 1, negative 4. Double checking my math. That was embarrassing. And if you think you notice any patterns, let the math do its work. So row 3 and row 2, so I don't do any damage in here. They're opposite signs, so I'm going to add them, and they're actually the same number already. Because I'm adding, I can add in the opposite order and not actually fail miserably, because adding in both directions is the same. So 0 plus 0, negative 13 plus 13, negative 1 plus negative 1, negative 2 plus negative 4. Okay, finally. And I'm sure it's right this time. This says 0z is equal to negative 6. That is impossible. And because it is impossible, whew, there is no intersection. So finally we have one of those. And honestly, I would have gone back and restarted this video to show you a perfect solution, or I can show you what mistakes happen, which I actually have chosen to do regardless of how embarrassing it is, because I need you to know that this stuff is not easy. It is easy to make careless mistakes. All right, so here's the stuff. So yesterday, our matrix number 1 lesson, which was all points of inflection, was this stuff. Today, with the no points of intersection, in case I said inflection, with no points of intersection, so either your line of intersection or your no intersection, it's same page but different numbers. And then remember that you did all of this stuff with elimination and substitution from that red textbook, so you could go back and do any of these. Now, I would semi-cheat with this stuff. I would flip to the back of the book and see what kind of answer you are expecting, so you know and you're learning from doing this kind of stuff. So this, not so difficult. It's a point of intersection. You're going to end up with a point. But this stuff, kind of prepare yourself for what the answers are and then see if it actually works out, and then you don't run into the mistake that I ran into and finding your mistake while you're accidentally flipping through your pages and you have to go back and fix it. Okay, so that is matrices. I think that's it for the course. Yay!